Thank you very much for inviting me to be here, and I'm very happy to share with you my ideas about new technologies for food processing. And I'm going to talk. We have been talking about agriculture production, and we are producing a lot of nice and high-quality agriculture products, but they have to be transformed in added value food products that can reach the consumer. And cities are going to increase in the future, and of course, these products have to be suitable for the consumers. I organize my presentation to share with you my ideas in two different parts, because I think they are the main drivers of the new technologies that will be implemented. So one of them is regarding with consumer needs. I mean, we have to produce these foods that the consumer wants. And this connection is quite important, and the technologies that you'll select are also have to be connected with what the consumer wants. And that, of course, a lot of things have been said before: healthy and tasty products, convenience. I mean, you can compromise a lot if it's convenient, and this will not give up, but it's a major driver. Tailor functionality, and is connected also a little bit with personalized products. You want food for specific groups, kids, elderly people, active persons, women, different ones. And this is important, how you select these technologies. And as said also before, I mean, there is in general negative attitude towards processing. If it's processed food, it's not good. And this is something that we have to fight and select technologies in the way that also the consumer will care and trust that foods. The other part that I believe is also very important is connected with sustainability and economy. We have been producing processed foods for many years. And of course, there is still a large potential to do better what we have done before and to do it different. And that's what I think drives the other part and the technology development, because it doesn't need to be only on processing or food processing operations. Can be other kind of technology that can help to make this food processing more sustainability. And I mean, Internet of Things is one of the examples, and many other things. But I will go through them just with some examples, because it's short time. And I go to regarding these consumer needs. I will just shortly go through this, and I think I go directly to them. I mean, the first is no thermal processing. We have heard this also in the introduction. This is something that has been merging, and it will come. There is a number of technologies that you probably heard about. Plasma technology is very effective in activate sporus. Ultrasounds can inactivate microorganisms and can also influence the properties of the foods. Pulsed electric fields, high pressure processing, membrane processing. What's common on these ones, and you could find others, is that they do not influence they are no thermal. So which means that a lot of the active compounds in food can be preserved. So it has this impact that the consumer wants, little processing, although some of these names can be a little bit scary for the consumer. But it's important that it goes hand in hand. These are equipment available, others are merging, but gives a lot of potential, in fact, to do more, for example, healthy foods. I would say that it's a major issue, but they could also contribute to make some of the processes more effective. And another part that I believe is going to increase a lot is more powder formulations, and comes with this ingredient, the need to create new ingredients and to transform the raw materials into active or functional ingredients, I want to say. So, I mean, powder formulations, it's not only from the food area, it's quite a lot of interesting also from the pharmaceutical industry and chemical industry. There are a lot of new technologies that can allow us to make these functional powders in a good way. And here is also a connection between formulation of foods and then transformation in the specific particle that can have a specific function, for example, in terms of digestion. I mean, one example of functional powders, I would say, for example, the Nestle cappuccino foam. So you can make a foam out of a powder. It's just your imagination that can stop what you can do. And I mean, a lot of these powders are produced by spray drying today. There is still a large potential to develop further spray drying, but of course there are many other technologies that can be used for powder formation and encapsulation technologies and coatings and so on. So I think this is something that we will see more in the future. I mean, this is just another example. This is from ETH, Professor Eric Wintab, about spray chilling. I mean, you don't have either to use heat to produce these powders. You can use characteristics like crystallization to make powders with no impact on heat. Structure processing. I think we are going to eat more snacks in the future, but we need to have more healthy snacks. And I think we look also for different characteristics in foods. And I pick up a little bit 2 examples. It could be more. There are other technologies, but just to give an example, I pick up high pressure processing that you can modify the properties. For example, in this case, I put of lactoglobulin, and you can influence the structure of, for example, your yogurt, that you can get different textures. It could be also of your drink. You can have drinks with the different textures that can be more appreciated by the consumers and makes also that your product can differentiate for others. Of course, 3D printing, we have been talking a lot about. I cannot miss it either because it will give also a lot of opportunities to create different structures and different forms in foods. There are already, TNO in Holland is working a lot with 3D printing, and I think also this is something that will merge and develop further in food because it gives a lot of opportunities to do processing also more close to the consumer. Can be, for example, in the elderly home, can be in schools. You can produce some products directly in the local where the consumer will be eating or consuming them, which can also improve the trust for food. I mean, one thing I believe also that's still not enough explored is these combinations of packaging and processing. I pick up some ideas. I mean, the first one is this pulled pork. It's merging a lot in Sweden. I don't know if it's not same. And then, of course, you pack the food. The meat gets very tender. Home is very convenient. It takes 10 minutes and you have the food ready to serve. I mean, Mikpak, that is also a Swedish company, is producing these ready-to-eat meals. They start is for microwave heating, but the process is also developed in a way that you combine, in fact, in-pack processing with microwave. And of course, I mean, atmospheric, modified atmosphere for salads. But I mean, I could imagine many other applications because I think quite often we forget this. We process the foods and then we pack them. I think you should look more to combine both from the beginning in your process design because can give you also a lot of other opportunities for development of new concepts. Regarding with sustainability, I mean, I just take this with improving process efficiency. And I mean, usually we say like this, if we go to a factory, we do a lot of consulting, or we did in this work that I had before. If you go there and you want to improve it, I mean, in an unautomized process, you quite easily can reduce, for example, energy consumption by 50%. And if the process is optimized by, for example, changing technology, you can eventually reduce more, 10% or even more. So I put this an example of in terms of energy, but you could think about water consumption, you can think about waste and byproduct generation. Process optimization is back to into food activities because there is a need to reduce and to make the processes more efficient. And sensor development is very connected with this, being able to optimize processes. You can look at technology shift. There are alternative technologies. I mean, for example, baking. I mean, baking has been done in traditional way for many years. If you do baking with microwave, for example, or infrared technology, you can reduce significantly both energy, baking time, and in fact you can produce new products. I mean, reuse of energy at factory level. There are also new technologies available that you can combine streams and make the process more efficient. It's quite easy to make money on this energy optimization. And of course, you can also think about holistic approaches at factory level where you use energy between different steps of the production. One thing, this work is from Wageningen, from Holland, and this is about process intensification. You talk about agriculture intensification, you can do also the same on the processing side. I mean, a lot of traditional processing operations have been developed, I mean, like maybe scaled up in many cases, I mean, either for chemical industry or from cooking. And there is an enormous potential to think new. You should rethink, in many cases, your process, because you may be able to do things with, for example, less water. And that's what you see in the blue line is this process for separation of wheat, flour, in starch and gluten. Many food processes uses a lot of water by tradition. And there is a lot of potential to do things in another way and reduce consequently the amount of water. I mean, many processes, for example, you eat and then you dilute and then you eat and you can in fact concentrate operations in the way that can make the process much shorter, much more efficient. So this is also a lot of activities on the chemical engineering side with this process intensification. And I think this is something that has also a place in food. This is just an example. For example, when you do, for example, many powders, if you are mixing a powder with a liquid, quite often you need a lot of water to be able to mix properly this powder. And in many cases, afterwards, you have to remove the water because you don't want it there. You just put the water because you need to mix properly. If you think about it, you can, for example, make this powder into snow, let's see, dry powder, and then mix it with the dry ingredient. You can do it much more effective. So, and you save a lot of energy and a lot of, product quality can also be better. So it's just an idea. High quality products for ambient storage, I think is something also to come. Is a lot of interest, and I believe is a lot of interest in Ireland as well, because it gives also a large potential for export if the products have a longer shelf life. And of course, I mean, this is just an example for milk, and it compares the cold storage with ambient storage from an environmental point of view. And of course, I mean, if you have very short distribution time, if the product is consumed, for example, in case of milk, in 1 to 2 days, in fact, it's better to do cold storage. But if you look at long time storages and you have long distribution chains, then in fact better to go to ambient. And there are also a merging of technologies to produce high quality products with ambient storage. This is one example, high pressure processing that you can do sterilization. There are large projects going on between US and UK, in fact, also, where they are developing this technology, and I believe to be soon commercially available. So I just put this picture a little bit about this bioeconomy and regarding with the use of more unconventional biomass for food production. This is also something that is been discussed, and I mean, you can think about these alternative sources of protein for food, but you can also think about for feed, because it could also improve quite a lot the sustainability of animal production. I mean, in my view, it's quite a lot of need of safe and extractions and fractionation technologies, because you want to obtain the specific proteins. And I mean, and I believe also that, I mean, you have to think about a sustainable chain all the way. So it's quite a lot of activities in this area. I think it's important, especially, for example, Lilia, which could also be relevant here. That has good potential to develop new products. And I mean, just to finalize a little bit, some inspiration also from Sweden. I mean, many food chains are quite long, and at least in Sweden, it's been discussed quite a lot this to make the food chains shorter. And of course, a better integration between the agriculture production and the food production, I think, can give also a lot of advantages in terms of product quality. And this is like a mobile slaughterhouse that a company has developed. And so they move this slaughterhouse to the animal that has to be slaughtered. And in this way, the animal doesn't get stressed, so you get much better meat quality. So this is being demonstrated now a lot in Sweden, also in connection with meat quality. But I mean, we could use this picture and think about other scenarios. I mean, spray drying may be done at farmer level, and many other operations. So a better integration between food production and these processing operations, I think, is also a way and something to consider in the future. And that's what I had to talk with you, so I will be available if you have questions. Thank you.